Welcome to the Head Shepherd podcast. I'm your host, Mark Ferguson, CEO at Next and Agri International, where we help livestock managers get the best out of their stock. Before we get started, a big thanks to our three fantastic sponsors. Allflex, part of MSD, perhaps better known as Cooper's Animal Health in Australia, offers one of New Zealand and Australia's largest livestock product portfolios with a comprehensive suite of animal health and management products. Heininger is a one-stop shop for wool harvesting and animal fibre removal. The Heininger team have a deep understanding of livestock agriculture, backed by Swiss engineering and a family business dedicated to manufacturing the best. ProA Livestock Equipment have been delivering industry-leading livestock handling systems to producers across Australia, New Zealand and beyond for the last 25 years to improve on-farm safety, efficiency and profitability. We are grateful to our sponsors for their support, helping us bring Head Shepherd to you each week. And now it's time to get on with this week's episode. Merry Christmas and welcome back to Head Shepherd, everyone. This episode's going out a couple of days prior to Christmas or a few days prior to Christmas, wherever you are in the world. Thanks very much for listening throughout 2025 and hoping you're having a great festive season, getting together with friends and or family and celebrating that time, which is always a great time. I will be in India by now and celebrating with family and friends over there, which is going to be great. This week on the show we have Dr. Sarah Preston. Sarah is an academic at Federation University in Ballarat. She's also one of the founders of Swabtec, a company bringing a new opportunity to select for worm resistance in sheep. And we have a great chat with Sarah around that test that she's developed, which was part of her PhD, as you'll hear. It's been sort of simmering away in the background, has now taken the opportunity to bring that forward and hopefully get that through to commercialisation. She's doing a lot of validation at the moment, or the company are, and really exciting opportunity for the sheep industry in Australia and hopefully the rest of the world as that technology gets validated. Before we get into that, just a quick shout out to Sarah's brother, James. I hear that James listens to the odd episode of Head Shepherd, so I wanted to say good day to James and thank him for listening along. And I hope he enjoys listening to his sister today. Righto, we'll get underway with this week's show with Dr. Sarah Preston. Welcome, Sarah Preston, to Head Shepherd.
Thanks, Mark. Thanks for having me.
Great to have you along. We're going to talk a lot about parasitology. It won't take me long to get out of my depth, but we might just start with your background, growing up on a sheep farm and then, sort of PhD and all that sort of stuff.
Yes, I grew up in the Riverina in a small town called Temora, which is sort of famous for, it's in part of the sheep and wheat belt. So I grew up, on the farm there with, so I guess, the family farm's been in the family or in the Preston name ever since it was sort of, farming area. So a lot of history there. So mainly, cropping, canola, wheat, merino sheep and cattle as well, beef cattle. And, grew up with an older sister and a younger sister and a twin brother who also has found his way into the sheep world, but probably, he was always obsessed with sheep. So he had his own sheep flock and has become a doctor of wool science as well. So, I guess, I had a good time growing up in the country. But, parents were both teachers as well as farming. So they really encouraged all of us to move away, go to university. We weren't allowed to have a gap year. We had to go straight into higher education, which is, it turned out really well for most of us. So,
I don't even reckon gap years existed when I went to uni, but anyway, they certainly do now. But,
Yeah.
Cool. Yeah, well, sounds like a whole lot of overachieving. That's a pretty overachieving twin set, 2 PhDs, but excellent. So now at Fed Uni and recently running Swabtec?
Yeah, so I did my undergrad at Monash Uni, and I guess, growing up, I was always interested in animal health and, trying to save the animals that are about to die, sort of thing. But I don't know why, but never really interested in going down the veterinary pathway. So, I studied science at Monash, and then in my honours degree, I actually found a lab that was working in asthma, trying to develop new medications for human asthma, but they were actually using a sheep model to study asthma. And, so they would inject house dust mite, which is a common allergen. And then the sheep the lungs would start to develop asthma-like symptoms very similar to humans. So found my way doing honours there, learning about the immune response there. And the same lab actually did a lot of work on worms in sheep, because that same response to asthma is the same response that worms have, or that sheep have to worms. And it just sort of made more sense for me when I was looking for a PhD after honours, because I found that I really enjoyed the research side of things. Sort of connected back to, being on the farm and Dad drenching a lot and sheep dying of worms. And I was like, they were working on a vaccine at the time as well. So that sort of seemed like a really good pathway to continue on my research in my PhD. And so my PhD I worked on was funded by the Sheep CRC, the scholarship there, and looked at how the immune response works to worms in sheep, and particularly looking at what's the difference between sheep that are really resistant to worms and those that are more susceptible. So that was really good. But unfortunately, like in research, funding stops and you can't really continue. So I had to switch and find a postdoc, and I was able to find one at Melbourne Uni, but I sort of switched from trying to understand the immune response to worms and looked more at developing new drenches. So started up a drug discovery program there at Melbourne Uni. Did that for 2 years. And again, then funding started to sort of wrap up. So sort of was lucky enough to be encouraged to apply for a academic position where I could still do my research, but I've got a permanent job with the teaching. So I was able to get that position at Federation Uni in Ballarat. So I've been there for I think 8 years now. And again, sort of trying to develop different research projects depending on what funding's available. But in the last 3 years was able to get funding to continue some of the work I was doing in my PhD to try and see if we can come up with a better test to identify worm-resistant sheep. And that's where Swabtec was born. So we were able to get some funding from the Victorian Sheep and Goat Compensation Fund, which is Victorian levy money, to support the initial work, where we were looking at using saliva as a way that we could detect worm-resistant sheep. You can obviously do it with blood, but saliva is just something easy for farmers to collect. The other good thing about saliva is because where the worms infect the animal, that's in the gut, and the saliva and the gut are linked through the mucosal system, and it circulates just like the blood does. So ideally what you want to be measuring is what's happening in the gut where the worms are. But if you do that, you've got dead animals. So not really practical. So, using saliva is a sort of proxy measurement to work out, what it is that sheep are doing to try and limit infection. Has been, quite a lot of work, even in the early 80s, trying to work out why some sheep resist infections and others are really susceptible. And that's across different breeds, but within the merino breed itself. I guess, in the 80s, there seemed to be a lot of more money for research with the wool prices. So a lot of, work was done. So, we sort of built off that original work, trying to develop a test. So
excellent. And I guess just to go back a step, I think and most people are aware, but I guess we've got lots of reasons why we want the sheep to be more immune to worms. One of them is that we're running out of drenches because your funding got cut, or for a range of other reasons. But as in, our ability to treat worms is always on a knife edge, I suppose. We've been lucky to have new drench families sort of arrive in time as others have failed, but you're never quite sure how long that pathway is going to last. And I don't know, the evidence at the moment suggests there's nothing much coming our way at the moment. So we're stuck with the chemical groups we've got currently, which means we have to be really careful using those because they are an important tool in the fight against worms. But I guess building sheep that do their own fighting is something that we're both fairly interested in.
Yeah, exactly. Yeah. So, I don't think, it's hard to know whether a new drench active will come out, but generally when there's a problem in cattle, you'll see something come through that will eventually hit the sheep market. And I guess anything we can do to reduce the frequency of drenching is really important. I remember, my PhD listening to a really good researcher from South Africa, and he always talked about the key things that causes drench resistance being frequency and underdosing. So I think, to be able to preserve actives for a lot longer, then we need to be thinking about how we can limit the use of drenches and only drench when needed. And I guess that's where worm egg counts are really useful as a sort of decision support tool to try and reduce that frequency.
Yeah, for sure. And I guess if we talk about worm egg counts, which is most stud breeders' sort of worst couple of combination of words, because it means collecting a lot of fecal samples, which is kind of one of the key reasons that Swabtec's of such interest is hopefully, well, not only should it be more targeted, it should actually take us a horrible job into a much more pleasant one. But I guess from a breeder's perspective, I suppose, the limitations of FEC would be good to run through, independent of the horrible job that it is, but just in terms of the different worm species and what we're actually measuring in an egg count. Yeah,
so with the worm egg counts, I think most producers or most of your listeners will be aware that you're measuring just the eggs in the faeces, and it's generally counted under a microscope, or there's more automated systems these days as well. But essentially you need to be, it's only measuring eggs from the female as well, and you'll have in that stomach of a sheep, you'll have males and females. You also have mixed infections. There's very few farms that will have just a dominant worm infection. And so for infections that are dominated by Haemonchus contortus or Barber's pole, then that worm egg count that you get generally correlates quite nicely with the adult population that's doing all the damage, like sucking all the blood. But for the other worm species, that correlation is not very clear at all, and particularly for the small or brown stomach worm, that correlation doesn't exist. So that worm is quite unique in that it actually regulates its adult population. So as soon as there's too many worms, it'll stop producing eggs. That's quite a dominant species in southern Australia. So yes, you really need to, I guess, for breeders, the threshold has been a big problem for them. So especially in southern Australia where it's not common to get high infections. And so we've been trying to develop this saliva test for almost 2 years and trying to benchmark it against the current worm egg count. And because Victoria was in drought over the last couple of years, it's been very difficult to try and get this matched worm egg count data because of this threshold that they need to reach. So it's 300 eggs per gram. And even then, that's quite a high infection for a small, like if your sheep are infected by this brown stomach worm, it's actually quite a high infection. So there have been reports of farmers losing sheep by trying to reach this target just so that they can essentially work out which animals will respond better. And it sort of does contradict what good worm management should be, like trying to really push your sheep, trying to, make the paddocks wormy so that you can put sheep out there, work out which ones are going to respond and cull the susceptible ones. It's, going against, best worm practice management. So, it's sort of one of the main drivers for developing something that's a bit different, but still will be able to tell you which sheep are able to respond better to infection. Yeah,
I guess it's been a very blunt tool. It's been some good progress made using a blunt tool, which is just the power of quantitative genetics, really. But there's a lot of error in that measurement for lots of different reasons, obviously a big challenge to get. The reason we have to get those thresholds up is so that there's less animals in there with no worms, and it's a whole. There's some good stats reasons why it has to go up, but it creates lots and lots of challenges for those breeders, particularly in drier areas where there's not a natural. Well, in those areas they might not ever get a natural challenge, and therefore they can't participate in that at all. And so if they're selling rams into a high rainfall area where worms might be more, or worm resistance is important, they struggle to get the data. So there's lots of reasons why a new test will be warmly welcomed. And I guess maybe obviously without telling us anything we shouldn't know, but it's obviously built on a saliva-based test. Can you actually explain sort of roughly what you are measuring in the saliva?
Yeah, so it is, you're probably aware, and some of your listeners are probably aware, there is a saliva-based test in New Zealand called the CALA test. So it's a very similar concept. We're measuring an antibody response that we know is really important for sheep to limit worm infections. And the other good thing about measuring antibodies instead of measuring worm egg counts is that antibody response starts to develop as soon as they're infected by that L3 stage. And then they actually molt 3 times to get to adults, and that can take about 28 days. So they're constantly molting and moving through before they actually start to mate and produce eggs. So you can measure this response quite early in an infection. And as the worm molts through to become an adult and start producing eggs, it does change. So, every time it molts, it changes what's seen by the immune response as well. And that's sort of a big challenge for the immune response, because every time it molts, they're actually fighting essentially against a different organism.
Is that right? It's amazing.
Yeah, so it's one of their really cool evasion strategies, worms. The other thing is because they're so big. So we talk about immune responses to bacteria and viruses. The main response there is actually immune cells eating them. We call it phagocytosis. And it's because they're so small that our immune cells and sheep immune cells can actually eat them up and digest them and get rid of them. But because worms are quite big compared to our own immune cells, they can't actually eat the worms. They can eat up or get rid of some of the molecules that the worm releases as it starts to feed to break down tissue. But we also know that worms will release molecules to turn off the immune response too. And so that's what we're measuring a response that the sheep produces through antibodies to shut down a response from worms that will turn off its immune response. So it's, pretty sneaky, the worm being able to sort of co-evolve with ruminants. So it's got really good strategies to make sure it establishes an infection and reproduces, because that's what it wants to do at the end of the day. So, with co-evolutions, sheep have been able to develop responses to limit this infection as well. And that's one of the key responses, is actually blocking this response.
Yeah, fascinating stuff. I always learn something on this podcast, and it's certainly had no idea that as they molt, they essentially can go undetected, which is very clever if you're a worm.
Yeah, just on that, I guess, that's because they're obviously been trying to make vaccines for a long time against worms, and that's one of the key challenges, is that each time it molts, it's a different organism. So a vaccine would need to have something in there that's part of each of the different stage to be effective. And so hopefully we will see a vaccine against multi-species worms. Like Australia does have the Barbavax vaccine specifically for Barber's pole. And I know there is work ongoing for a scour worm vaccine, but that's been one of the challenges as well for vaccine research, is trying to push the sheep to make a response against multiple different stages of the worm.
Excellent. Is it, obviously I've only thought about Swabtec in its role in breeding, because that's what I think about, but could it be diagnostic as well? And like the same as we use a worm egg count, is that something that it would be good at? Or
we get a lot of questions about that. And so our primary interest at the moment is a breeding tool.
Yeah.
But I think with thinking more about it, it's definitely could be used as a more management tool. So if you are really keen on this, some rams or some ewes because of other production traits, and you were able to measure that immune response and know that they're not that great at developing natural immunity, then you might say, okay, well, I still want to keep them, but I know that I have to be on top of them for drenching and worms. Another way in which I guess the industry has been pushing to try and, save the drenches and make sure they last longer is these targeted selected treatment, where you only target the ones that need drenching. So then the other sheep that aren't drenched will have this population of worms that aren't exposed to chemicals, so they won't be resistant, and then it dilutes out the resistance that's developing in your worm population. Potentially you could look at using this as probably together with body condition score or live weight to do a targeted treatment approach. But for the main drive at the moment is a breeding tool.
You could phenotype maidens, for example, and know where they sit on their immune response, and so maybe when you've got a big worm challenge on, you drench everything, but when it's a light challenge, you only drench the ones that you know that haven't got an immune system good enough to do anything about it. So.
Yeah, exactly. Yeah.
Cool. Well, I guess anyway, I won't go further down that rabbit hole. You're obviously you talked about deciding to validate a test in a drought, which there's nothing surer to stop it raining than to try and run a worm trial or a full rock trial or something where you actually need moisture. It's almost guaranteed that it'll stop. Obviously, you're into that validation now? How's the confidence that you're onto something?
Yeah, so one of the good things about the saliva test is that even though there wasn't much of a worm challenge during the drought, there was still antibodies present. So what really stopped us was the benchmarking against the current test that is quite highly dependent on moisture. But yeah, we've been able to, we had a target of 4,000 tests that needed to be done paired with worm egg counts. And we've been working with Agbu and Daniel Brown that I saw has been on this podcast before as well. So he's been helping us with the analysis. And we've got about 2,000 tests done on merinos, and the other portion were mainly shedding sheep. And we just got our first report back a few weeks ago on our merino sampling with the heritability score of 0.4. So we thought that was quite promising. And we're still just awaiting the final analysis to look at how it correlates with other production traits.
Yeah, excellent. Yeah, and that heritability is pretty exciting because the other health trait, worm whack type traits are normally about half that. So high heritability means faster genetic gain, means so anyway, that'll be good results so far. So hopefully long may they continue.
Yeah.
In terms of, I think I know the answer to this question, but I'm assuming because we're not just measuring the outcome of females, but so this test should be more sensitive and more, I guess, specific. And so in theory, we can, and maybe that's why we're already seeing a higher heritability, is because you're able to explain more of the genetic variation. Yeah, I guess this should be a more powerful test to find those worm-resistant animals because it takes a lot of the noise out.
Yeah, exactly. Yeah, and I think in those places where worm egg counts, getting to that threshold is not what's limiting them, and maybe it's more that they don't like collecting poo, but they could be using both tests in combination to really accelerate being able to produce, or having that genetic base that are naturally more resistant. And that's probably really important in areas that are dominated by Barber's pole, where, getting that threshold isn't generally a problem, but that's where we're seeing a lot more of the drench resistance problems because that, worm reproduces so quickly, it lays lots of eggs, those mutations to drenches comes through really quickly as compared to places where they don't have homunculus or Barber's pole, but they do have worms that cause a lot of damage, but they just can't do that worm egg count test. So, this sort of saliva-based test would be an option for them to start being able to breed sheep that they know will resist infection better. And like you said, just being able to sell to those clients in higher rainfall areas that are really wanting to know how good they are going to be with worms.
So worm egg count is picking up something that the saliva test isn't? Like they're not, are they two sides of the same coin, or are we two different coins we're playing with?
Yeah, it's a really good question. And it's hard to answer because of that, variation in the worm egg count response. But what we've seen so far with our raw data is that those sheep that have much higher worm egg counts than the rest of the flock are the ones with lower antibody responses in the saliva. And those ones that have got high antibody responses are towards the lower end of your worm egg count. But we're not seeing a direct correlation between the two traits. This is just the raw data and the phenotypic. We haven't looked at the genetic correlation yet. We're still waiting for those results to come through. But essentially the IgA is really, or the antibody response is really picking up the defense against the adults and the adult stage, as opposed to how many females are producing eggs. So in a worm-resistant sheep, they will also eventually have quite lower worm egg counts too. But in some situations, you might have low worm egg counts because you've got too many adult worms in the gut, particularly if we're talking about the brown stomach worm that we mentioned earlier. One of the issues with the worm egg count and the reason why it takes a long time to see that genetic improvement is because, a low worm egg count doesn't necessarily mean less worms in the gut, because it depends on the species you're talking about, and vice versa, a high worm egg count. You might only actually have a couple of adult worms, and they've got all the nutrients they can to lay lots of eggs. So I think worm egg counts is really good to obviously reduce pasture contamination. And so, this test is really looking at the adult population and how much damage is being done there.
Yeah, right. sort of, for those of us who didn't listen that well at parasitology at university, kind of missed that whole thing, how when meat count can go down when there's lots of adults in the gut, which is obviously counterintuitive. But it's obviously that one species. So, yeah, anyway. So is that, I mean, we've all been monitoring mobs and seen those egg counts start dropping, and particularly when pasture conditions are good and the ewes are fat or the animals are fat and going forward. Are we just tricking ourselves? Is the worm population going down, or is it just the fact that there's heaps of worms in there and they've stopped laying eggs, or could both of those things happen?
Yeah, it's a pretty tricky question to answer. Again, the best way would be actually, having a look in the gut. But it's just hard to know what that reason is, and I guess that's why converting it to a breeding value does take a lot of that environmental effect out.
Yeah. So, like all traits, I assume we're heading towards essentially breeding value for this antibody that you're measuring. And so I assume in the fullness of time with genomics tools around, and like eventually we have a breeding value that's predicted both from the phenotype as also from genomics of related animals, like we do WEC now, basically. Is that how you see it rolling out?
Yeah, definitely think that, that's what we'd hope to do, is be able to have it integrated with an ASBV to take that environmental effect out, because even with the immune response, it's quite a dynamic response, and it will fluctuate with worm burden as well, but there will always be a response there. So definitely, I'm not quite sure on the genomic breeding values, but definitely the normal breeding values. There's been a lot of work trying to identify particular genes that are responsible for the immune part of why sheep is more resistant to worms. And there's been lots of studies, and essentially they've all concluded that there's lots of genes with really small effects, which makes a lot of sense for a immune response, because you want to have a lot of redundancies and you don't want to be depending entirely on one gene for your defense against infection.
I think that's almost every GWAS ever has shown that lots of genes are at play, and that you need to measure the trait and then pretty quickly happen. Yeah. Just to clarify, our current test, obviously, when we're trying to find worm resistance, we need to get lots of worms, eggs on, lots of worm egg count, so we can find the good and bad individuals. With the Swabtec-based test, we just need to have adult worms present, so we don't need to have squillions of them. We just need some infection level to measure the antibody level. Is that right? But
not only adults. It's what we're targeting is secreted by L3s, so that's the active stage on the pasture. So as soon as they get eaten by the sheep, they will start to molt and get rid of the cuticle, we call it, that protects them on pasture from the environment. So they'll get rid of that within 24 to 48 hours, and then they'll start to develop into L4s. So that's, the L3, L4 and adult, we're picking up a response to all those three stages there.
Oh, righto. So if they're either eating worms or have a worm, then it'll pick it up.
Yeah, because the whole idea of, what we're trying to block what the sheep is trying to block when we're measuring the saliva is it's trying to produce, the worm's trying to spit out this molecule that shuts down the immune response so that it can establish. And so that's what sheep are trying to block, and that's what we're trying to measure in the saliva.
Intriguing bit of stuff that, I'm getting close to understanding, but I reckon if I hear you talk another 10 times, I should be onto it. If we kind of everything goes to plan, we're out 10, 15 years' time, do you see a day where we sort of don't need new drench families because we've kind of got an animal group that is, and we can, we've got animals just resistant enough that we don't need to drench adults. We're only drenching a few young sheep, and therefore we're sort of not putting as much pressure on our drench families?
Yeah, I definitely do. And I mean, some properties are already doing that in certain areas, like they don't drench their adult sheep at all. I think there's definitely need for drenches still into the future, but anything that we can do to limit our reliance on them. And I think, in Australia and obviously New Zealand as well, we've got, quite sophisticated breeding programs that other countries don't have. And they've still got the same issues that we do with worms and how much they lose on production and kill animals. But yeah, in Australia and New Zealand, we have this ability to be able to measure these responses and then look at how they relate to other key production traits and identify those outliers that can perform well productively and also have a strong immune response. Because I guess that's the other thing. Some of the earlier work also looked at the cost of immunity as well, and how some particular responses does use a lot of energy from the sheep. And so while they're trying to fight off infection, they're actually losing out on producing wool or meat. So there is sometimes a trade-off in the cost to immunity, but there are these animals that are able to limit the infection quickly and carry on and still be quite productive. And so those are the ones that we want to be able to identify, I think, and hopefully, spread out across Australia and New Zealand. Yeah.
Yeah, it's a really good point and something that I feel like I'm talking about daily around that. Yeah, we've got to be, it's a tightrope we're walking, trying not to, if we just have an animal that's just fighting worms and other infections all day but forgets to be productive, then that's not the one we want. Yeah. Or if it's, so it's that kind of that tightrope that we, and that's the joy of, I guess, or the beauty of moving in the breeding value world, where we can we can do that with a bit more accuracy than we could if we're just, I don't know, selecting on phenotype or whatever. Changing gears slightly, I'm just interested in, I guess, in the last few years and how you've found going from kind of the academic world, doing lots of research, and then moving that through as a sort of a startup in Swabtec, and I guess some of the challenges you've had in that process, or how much fun that's been, and also as part of that, well, what I'm hearing from farmers is they're really receptive to this new tool, and I guess just your perspectives on the last couple of year journey, I suppose, in going from researcher to entrepreneur.
Yeah, it's a pretty fancy word, but no, it's been good. I guess growing up on a farm and being like all my uncles were farmers and having that history, it's been good to be able to have an avenue where you can actually take your research and have a real impact. So I think researchers can get caught up in just writing papers because papers give you grants and then you get promoted and you're doing a lot of creating new knowledge, but it's really only impacting the immediate researchers in that area, and that's sort of rare that you actually get an opportunity to have real impact or direct impact with your research. And so I guess that was one of the key reasons for trying to go down a more commercial route with this research when we got some really positive results. And so far it's only been less than a year that we launched Swabtec, and though it feels like we've been around for a long time, that's a lot of pressure and stress. I'm still at Fed Uni, still got my teaching role, still supervising 4 other PhD students, have honours students. Also have a family. So,
This is between 10 p.m. and 1 a.m. sort of setup.
Yeah, but pretty lucky that, universities are really supportive of a startup, and can see the benefits that we can have to the regional communities that we serve as a regional university. So, I can still work on the company while being employed at Fed Uni, which is pretty unique. I don't think a lot of other universities have that sort of model. And they are also quite, they've assigned their IP over to Swabtec as well. So that just helps push through, commercial options really quickly as well. So, it's been good, and hopefully we will be able to keep going and stick around for, a long time, because, we have been doing a lot of startup programs, and there's a little bit of money around for startups, particularly in Victoria and in ag tech. But we hear a lot about startups not being around for very long as well. So hopefully trying to avoid that.
Yeah, I'm feeling confident. But I think it's a fantastic bit of technology and something that's going to have a massive impact. So I'm confident you'll still be here. We managed to get through 7 or 8 years now as next gen, so avoided the death so far. But I think it's awesome, and really looking forward to seeing it roll out across the industry. Obviously, it hasn't hit the shores outside of Australia yet, but once that validation gets done, then there'll be lot of interest all over the place, I'm sure. There's a couple of questions we always ask on this podcast, and we'll do them again today. What's the last thing you changed your mind about?
Yeah, this is a hard one to answer, which I think a lot of your speakers say too. But yeah, I think thinking about I guess starting up the company, and I guess I guess, and also coming more from a research science background, I guess the reason why we thought a new test was required or needed by industry was because the worm egg count itself can be inaccurate depending on what species you're dealing with, but also because we thought producers didn't like collecting poo. But actually that's not what the real reason was. It was actually more that they actually can't do the test if it's in dry conditions, or if they're in areas where they just don't reach that threshold. So I guess that's sort of what we've changed our mind about why something like this needs to be commercialised for the industry.
Right, cool. Yeah, good points. And the final question is, who's the best human you've had the pleasure to learn from?
Yeah, I think I'll do humans, and definitely be my parents. Sort of talks about growing up on the farm, and went through quite a few droughts. The longest one being when I was a teenager, like a 10-year drought, carting water constantly, paddocks turning into deserts. But still, Mum and Dad were able to raise 4 kids, send us off to university, and do that, and still be happily married, I guess. So I think I've learnt a lot of their resilience and, drive just from what they were able to do growing up on the land, because it's obviously fun to be living in the country and farming and everything like that. But, it obviously comes with its own challenges as well.
Yeah, excellent. Yeah, it very much resonate with me on that front. Growing up in the Mallee, saw plenty of droughts, and Mum and Dad battling away. Well, awesome, Sarah. Thanks very much for your time today. It's it's a great bit of technology, and really looking forward to seeing where it can go. And great to get you on here. It took a little bit of arm twisting, but it was great to get you here.
Yeah, great. Yeah, thanks for having me.
Cheers. Thanks. Thanks for listening, and thanks again to our 3 fantastic sponsors. Heinegger, who are proud world leaders in the manufacturing and supply of professional sheep shearing and clipping equipment. Allflex Livestock Intelligence, part of MSD Animal Health, offer extensive livestock product portfolio focused on animal health management, all backed up by exceptional service. ProWay Livestock Equipment offer turnkey solutions from design through to professional installation, and specialise in facilities that are tailored to your specific operation for all livestock species. We thank these 3 great companies for their ongoing support of the Head Shepherd podcast.